For number 9, we know that we have 6 Milky Way, 5 Snickers, and 3 Laffy Taffy in a bag. So in that bag, we have a total of 14 candies. I'm going to write that here. 14 total. So we're asked, what is the probability of choosing a Milky Way and a Snickers if there is no replacement? So I'm going to have this bag that has candy. I'm going to reach in and I'm going to pull out a Milky Way. The probability of me getting a Milky Way is going to be the total number of Milky Way, which is 6, out of the total number of candy, which is 14. If we know there's no replacement, then that means this is going to be a dependent relationship. Dependent will be shown with the probability of A times the probability of B after A happens. So the probability of A is 6 out of 14 because we're going to say that the first option was A. For the probability of B after A, so if you think about it, we had 14 candies and we took one of this Milky Way out. There's not going to be 14 candies anymore. There's only going to be 13. And out of those 13, how many of them are Snickers? Well, we're still going to have 5 Snickers. So if I multiply those together, that's going to give me the probability of A and B. Remember, the intersection is and, the union is or. So then when I multiply this across, I get 30 over 182, which is going to give me 0.16. It's 0.1648, but the 4 that would be right here is not going to make this 6 jump up to a 7. So the probability is going to be 0.16. Now we're asked, what is the probability of choosing a Snickers and a Laffy Taffy if there is no replacement? Again, there's no replacement, so it's going to be dependent. We're going to use this formula here. So the probability of choosing a Snickers, originally there's going to be 14 in the bag. Out of those 14, how many are Snickers? We're going to have 5 of them. We'll multiply that by the probability for the Laffy Taffy. If we chose one and we did not replace it, we took one Snickers out, there's no longer 14 candies in the bag. There's only going to be 13. And out of those 13, how many are Laffy Taffies? 3 of them. When we multiply across, we get 15 out of 182, which leaves us with 0.08. It's 0.082, but that 2 is not 5 or greater, so we are going to stay. Now, what is the probability of choosing 2 Laffy Taffy if there is no replacement? Again, no replacement, so we'll be using the dependent equation. So if we're looking at Laffy Taffies, the first one we pull out will be a Laffy Taffy. Out of the 14 candies, we had the probability of 3. We'll multiply that, and if you think about it, we've got 3 Laffy Taffies, but we pull one out. There's only going to be 2 Laffy Taffies left and only 13 candies left. So we will get 6 out of 182, which leaves us with 0.03 as our probability.